Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.139 and problem 3.140 from the book Thermodynamics and Engineering Approach by Cengel, 9th edition. So first I solve problem 3.139. So the statement of the problem is water is boiling at 1 atm pressure. Pressure is given to us is 1 atm, and we know that water boiling point of water at 1 atm is 100 degrees centigrade. Is boiling point of water at 1 atmospheric pressure is 100 degrees centigrade. So it means that temperature is equal to 100 degrees centigrade. A stainless steel fan on an electric range. It is observed that 1.25 kg of liquid water evaporates in 30 minutes. Mass given to us is 1.25 kg and time for evaporation is 30 minutes, which is equal to 30 multiplied by 60 seconds. So total time is equal to 1800 seconds. The rate of heat transfer to the water required is to find power. Power is basically a rate of heat transfer. So here we start solution. So we know that temperature is equal to 100 degrees centigrade, and to find Q, first we find latent heat of vaporization. So from saturated steam table at temperature is equal to 100 degrees centigrade, latent heat of vaporization HFG is equal to this is temperature column, this is 100 degrees centigrade, and this is HFG latent heat of vaporization, which is equal to 2256.4 kilojoule per kg. Now we can find Q. Now heat transfer is equal to mass multiplied by latent heat of vaporization. Mass given to us is 1.25 kilogram and latent heat of vaporization is 2256.4 kilojoule per kg. So heat transfer is equal to 2820.5 kilojoule. Now rate of heat transfer. Now we find now rate of heat transfer Q power is equal to rate of heat transfer is basically power. Rate mean per unit time. So Q is 2820.5 kilojoule for time is 1800 second. So rate of heat transfer is equal to 1.5 kilo, and joule per second is equal to watt, which is approximately equal to 1.57 kilowatt. So in the problem, option A is correct. Let me check it. So option A is 1.57 kilowatt. So this option A is correct. Now we solve 3.140. So water is boiled in a fan on a stove at sea level. So it is clear that at sea level atmospheric pressure is at sea level at sea level atmospheric pressure is equal to 1 atm, and we know that at 1 atm boiling point of water is 100 degrees centigrade. So it means that temperature is equal to 100 degrees centigrade. It is clear water is boiled, so we will use boiling point in a fan and a stove at sea level. So at sea level pressure is 1 atm, and at 1 atm boiling point is 100 degrees centigrade, so temperature is 100. During 10 minutes of boiling, it is observed that 200 gram of water is evaporated. Time given to us is 10 minutes. Time given to us is 10 minutes, and mass evaporated is 200 gram, which is equal to 200 divided by 1000 kilogram, which is equal to 0.2 kg, and required is then the rate of heat transfer to the water. It's basically power. Rate of heat transfer is basically power. Required is find power. Power is basically rate of heat transfer. So this is similar like problem 1.39. Problem 3.139. So solution. First we find latent heat of vaporization. So from saturated steam table at temperature is equal to 100 degrees centigrade, find latent heat of vaporization HFG, which is equal to 2256.4 kilojoule per kg. This is given in the steam table at 100 degrees centigrade. This is temperature 100. This is HFG 2256.4 kilojoule per kg. So heat transfer. So heat transfer denoted by Q is equal to mass multiplied by latent heat of vaporization. Mass given to us is 0.2 kilogram, and latent heat of vaporization is 2256.4 kilojoule per kg. Kilogram will be cancelled with kilogram. So heat transfer is equal to 451.28 kilojoule. Now rate of heat transfer. Rate of heat transfer Q is equal to power is equal to rate of heat transfer is basically power Q divided by time. Q is 451.28 kilojoule, and time given to us is 10 minutes. So rate of heat transfer is equal to 45.128 kilojoule per minute, and this is option B. So option B is correct. Option B is a correct option. So let me check this. So option B is 45.1 kilojoule per minute. So this is the correct option, and this is the end of these two problems. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.